Right, okay, year 12 furthers, here we go with the Matrices 1 video. So I'm quite enjoying doing this. Mr. Marshall's normally been hogging this topic, but I'm doing these, so that's quite good fun. 2, 0. Okay, so all I'm doing is I'm just popping A in there, so that's 3A, minus 2, and then I just put B in. And I'll just multiply that through, so we've got 6, 0, minus 9, then 3A, minus, and then 0, 4, 2A, minus 8. All this is really doing is just checking you don't screw up on the double negative. But we should get 6, and then minus 9, minus 2A, and then minus 4, and then 3A. That's going to be, we've got minus 8, so 3A plus 8. Okay, cool, and that's that one. Alright, on to the next one. Okay, so now we've got to do AB squared, so I'm going to do B squared first. So B squared, that's going to give us, that's going to be 0 to A minus 4 multiplied by itself, so okay, and then multiplying that together, so 0 times 0, 2 times A is 2A, and then we're going to get 0 times 2 and 2 times minus 4, so minus 8, and so on, giving us minus 4A and 2A, and then minus 4 times minus 4 is going to give us plus 16. So that's B squared. Then we want to multiply that by A, and so AB squared, there's a left multiplication, so A will go on the left, so we've now got 2, 0, minus 3A is going to be multiplied by, well, that's what we just found, 2A, yeah, minus 8, minus 4A, 2A, plus 16, and so that then will come to, so you got 0 times 4A, 2 times that is 4A, and then you're going to have minus 16, and then this one, so minus 4A times A will give you minus 4A squared, and minus 3 times 2A give you minus 6A, and the last one a bit trickier, 24 plus 2A squared plus 16A. Okay, good. Let's keep on going. Question 2 now. So we've got there's your matrix A, and we've got to work out A squared, so I've just written them out. They're multiplied by each other. So you're going to take your, to get the top left, you're going to take the top row of this one and multiply it by the first column of the second one. So that gives you 1 times 1, which is 1, and you've got a 0, so nothing else doing, and then 0, and then minus 4A. And then for the next one, you're going to have the minus 4 multiplied by the minus 2 to give you 8. Everything else is zeros. And then for this, as the third entry here, you multiply the top row by the right hand column, and that will give us minus 20. Okay, then for this one, for the second row, we're going to multiply the second row of the first one by each of the columns in turn. So if we just move on through now, minus 3A minus 3, A squared, and 12, and then for the last row of this, we'll multiply the bottom row of the first matrix by each of the columns in turn, giving us 5A plus 6 there, minus 8 minus 2A, and 16 minus 4A. And there we go. So 2 marks for that 3 by 3 matrix multiplication. Okay, coming on to question 3 now. We've got to multiply h by itself to give us h squared, so let's do that. So let's write it all out. So I'm just going to multiply by itself. Alright, okay. So if we do that, then we're going to have the minus 3 root 2 will multiply by minus 2 root minus root 3 over 2 will multiply by minus 2 root 3. So the 2's will cancel, the negatives will cancel, and the roots will cancel, just leaving us with 3. These two are just going to be zeros, and this one down here is going to just give us 3 as well, which is of course 3 times by the identity matrix, and so that means the Q is equal to 3. Okay, coming on to question 4. So find the 2 by 2 matrix which represents a reflection in the line y equals minus x. Okay, so if you've got the line y equals minus x, let's just draw this out a little bit here just so we can see kind of what's going on. There's your x and your y axis, and here's your y equals minus x. So let's just take a few points and see what happens to them. So say we take a point here, say this one, call that, or is that going to be like say 5, 1 or something? How the hell did that link onto that? Right, okay, 5, 1. So I'll call that one 5, 1, and we can see what's going to happen when that's reflected in this. Well, it's going to go down here, it's going to have to be definitely a minus 5, and it's also going to just go the other side of the axis, so it's going to go here, so it's going to go to minus 5, minus 1. If we just take another random point, so say we take one here, say we take like 2, 2. Where's that going to go? Well, that's clearly going to go down here to minus 2, minus 2. So what's happening here is that our x coordinate is mapping to the negative of our y coordinate, and our y coordinate is going to our negative x coordinate. So on the image, when it's been transformed, x dash, so that's the transformed one, is going to 0 lots of x minus 1 lots of y, and the y one is going to minus 1 lots of x plus 0 lots of y. So that means that x dashed y dashed is equal to the matrix 0 minus 1 minus 1 0 multiplied by xy. So our matrix is that 0 minus 1 minus 1 0. I'm just because we've done that from first principles, but I mean clearly that's the answer, and that's sort of how you would get there if you didn't have the knowledge beforehand. Right, describe fully the geometrical transformation represented by 3 0 0 1. So what I'm going to do again is I'm going to just draw this out. I'm going to take the unit, a little sort of, we might call it a little unit square, so just here, so that's going to be 1 and 1, and we're just going to sort of move each of these points in turn. Now, so clearly if I took 0 0, that's obviously just going to stay at 0 0, because if I multiply the vector 0 0 by the matrix, nothing's going to happen. Okay, let's take the point 1 0 now and see what's going to happen. So we're going to have obviously the matrix will act on the vector, so it will be this. Okay, tidy myself up there. Okay, and then that is going to be to 3 0. So our point 1 0 that was here is going to end up over here at 3 0. Let's take the point 0 1 now, which is here, and we can multiply the matrix onto that, and that will go, that actually stays where it is, so that stays on 0 1. Alright, okay, and finally let's take 1 1, and so I've got 3 0 0 1 acting on 1 1. Perhaps unsurprisingly that's going to go to 3 1, so that's here. So what we did have this this little unit square which we put in black here. Now it's been transformed to this rectangle here. So what's that transformation? Well, that is without a doubt a stretch parallel to x-axis, or in x direction, and scale factor 3. Okay, good. Okay, alright, so for question 5, we've now got these two matrices, and we've got to find the values of the constants a and b, for which aa plus bb equals I, I is a 2 by 2 identity matrix. So all that means then is that A multiplied by minus 3, 0, 0, 2 plus B 4, 0, 0 minus 7 over 2 is equal to the identity matrix, which is of course for 2 by 2 is that. So leading diagonal of 1s, everything else is 0. We can now just multiply these matrices out, so that gives us minus 3a plus 4b is equal to 1, and 2a minus 7 over 2b is equal to 1. So if you just plug those into your calculator, I'm not going to go through that again. So your a is minus 3 and b is minus 2. Okay. Alright, question 6. Okay, so we should be aware of our general rotation matrix. So this has got to be assumed knowledge. We've got to know this. So cos theta minus sine theta and sine theta cos theta. So then that will mean that, and of course, just a little find that theta is anti-clockwise about the origin. Okay, so what we're after is we need to find, for this individual question, we need to find theta such that cos theta is equal to 1 over root 2 and sin theta is equal to 1 over root 2. Now, either if we don't, we should probably know what this is, but one way to make sure of that is if we had a right-angled isosceles triangle with 1s there, we'd have to have root 2 there, and so in that case theta would have to be either 45 degrees, but more likely, as we're in radians, pi over 4. So we'll just go to radians unless we're told to go to degrees. It would probably be the better way to do it. Right, okay, now the next one is a little bit trickier. I may find myself needing an extra sheet for this. Okay, so we've got here a situation that we've got our matrix A. Now that is going to be multiplied by another matrix, and that's then going to give us the matrix C. So that means our situation will be for A, let's just duplicate that. Okay, so that is then going to be multiplied by another matrix, which we'll call matrix B, and then that's going to give us a matrix C, 1, 0, 1 minus 1, 1, 1. Okay, now what we can then do is we can use some of the results that we'd worked out previously to work out B. If we can find the inverse of this matrix, we could apply it onto the left hand side of both sides of the equal sign. That will remove this matrix from the left hand side, and it will then give us B equals the right hand side, which will be obviously this matrix applied onto 1 minus 1, 1, 1. So how do we find the inverse of the matrix? Well, we're going to have 1 over the determinant. So let me just bring this matrix over just so we can see what we're doing. So to get, we're going to want to find the inverse. So we're going to have 1 over we're going to have 1 over the determinant, so that's going to be 1 over so 1 over root 2 times 1 over root 2 is clearly a half. Then you'd have minus 1 over root 2. So you've got basically 1 over 1. So that's just going to be 1. And then to find the entries on the matrix, of course, what we just do is we swap over 2 of them and we make the other ones negative. So that's going to give us 1 over root 2 1 over root 2, minus 1 over root 2, 1 over root 2, which obviously then just gives us this, because that's just 1, and so we've got 1 over root 2, 1 over root 2, minus 1 over root 2, and 1 over root 2. So we're going to apply that matrix, so I don't know why that one moved out of the way, apply that matrix to matrix C now, and so we've got 1 over root 2, 1 over root 2, minus 1 over root 2, 1 over root 2, and we're just going to apply that onto, on the left of course, that, and that gives us 2 over root 2, 0, 0, 2 over root 2, and we can just rationalise the denominators of those, so that gives us root 2, 0, 0, root 2. There we go. Quite a long-winded 2 marks. There may have been a better way to do it, but I enjoyed that way, so that's what you've got. For C, describe fully the transformation represented by B. So we can see what we just worked out, that that B must be equal to root 2 multiplied by the identity matrix, so that means that we must have an enlargement about origin and scale factor root 2. Okay, alright, moving on to question 7. Okay, so for this one, find the matrix that represents a rotation of 90 degrees clockwise about O, followed by reflection of the y-axis, followed by an enlargement with centre 0 and scale factor of 2. Okay, so what we may just need to help us before we press on is just a little bit of trig graphs, just as we got some values that we will need. So I'm just going to change those over. Okay, and put another one on. Just so that we've got it. So we should know, of course, our let's do sin first. Okay, and we're just going to want just to get a value for minus 90. We'll just have that. So we've got 90 there, and clearly minus 90 will be there. Likewise for cos, down there. Okay, so we can say for sure that sin 90 is equal to 1, and sin minus 90 is minus 1, and we can say that cos of 90 is equal to cos of minus 90, which is equal to 0. And just putting those up there just to make everything nice and clear. Okay, so now if we refer to our general rotation matrix, so rotation of 90 degrees clockwise. Now, normally speaking, we defer to anti-clockwise. So if we're going clockwise, this matrix must be cos of minus 90 minus sin of minus 90. Again, this is just referring to our general rotation matrix that we talked about earlier. Sin of minus 90 and cos of minus 90. So this works out to be 0, 1, minus 1, 0. And we can just look up from what we've got in our notes, or indeed in our textbook. So our reflection in the y-axis, that's equal to minus 1, 0, 0, 1, and enlargement, scale factor 2, is equal to our 2 times our identity matrix, and so that's 2, 0, 0, 2. And now we just have to multiply these together. Okay, so the rotation is going to happen first, and that's going to be followed by the reflection. and so that's going to be -1, 0, 0, 1 multiplied by 0, 1, -1, 0, and that comes to 0, -1, -1, 0, and then we're going to follow that by the enlargement, so it's a left multiplication, and so that's going to be 2, 0, 0, 2 is then going to be multiplied by what we just got above, so 0, -1, -1, 0, which works out to be 0, -2, -2, 0. Obviously it does because it's just doubling the identity matrix, so we just double the values. Okay, so for question 8a, if we look up in our if you just look up in our notes or from the textbook, we'll find that we can find this the answer to this one, and that is that this is 1, 0, 0, 0, -1, 0, 0, 0, 1. Okay, alright, so that's just from our basic knowledge in our textbook. For part B, we can also look up from the textbook the rotation matrices, and we will know from that cos, so this is in 3 dimensions now, the cos theta minus sine theta 0, sine theta cos theta 0, 0, 0, 1, that is rotation about the z-axis. And so if we can look here, we can clearly see that this will match up because we've got the same things here as we've got here. Okay, so we can see that it's going to be a rotation at the z-axis, but all we need to do is find theta now. So we need to find our theta, so such that cos theta is equal to 0 and sine theta is equal to 1, and of course that happens at pi over 2. If we just again refer to those sin and cos graphs, there's sin and there's cos, and obviously just here you've got cos being 0 and sin being 1, and so there we go, that's all sorted. So we've got pi over 2, or 90 degrees if we're in degrees, but we're not going to talk about degrees. So we've clearly got a rotation pi over 2 radians, or 90 degrees, you really have to, anti-clockwise about the z-axis. And there we go, that was matrices 1, which I've very much enjoyed.